Dr. P here. For this video, I wanted to talk to you about rotational inertia. Now, we already know that inertia is Newton's first law of motion, basically. Inertia is an object's tendency to keep doing what it's doing or to resist a change in motion. When we talk about rotational inertia, it's talking about how easy is it to get an object to turn and how easy is it for an object to keep turning. When we talked about inertia before, we talked that like linear or translational inertia is proportional to mass. Remember, inertia isn't momentum. Inertia is not a force, right? Remember, momentum is P equals mv. Momentum equals mass times velocity. So inertia is not a force and it is not momentum. So linear inertia, you have more inertia when you have more mass. Even if you're sitting, you still have that inertia. Rotational inertia, same idea. Rotational inertia has to do with the mass of the object as well, but now it depends on where that mass is located on the object. I have a handy dandy rotational thing for us here. Okay, so if I think about this as being an object that can rotate, if I look at this in this direction, I have green things out here and I have orange things here. Now, you can imagine that if I have a lot of mass on the outside of this, that it's going to be really hard to turn. It's going to be a really hard to turn thing because I have so much mass out here that I've got to get going. Now, if I turned it this way, I no longer have those big radii out here. And so when I want to turn it now, it's a lot easier to turn because the mass is closer to that axis of rotation. So thinking about rotational inertia, it's all about how easy is it to turn an object or stop it from turning. Instead of turning, we could use the word rotating as well. So this idea of rotational inertia is given by the letter I. Older textbooks and a lot of teachers will still call this, and so will I, the moment of inertia. This is a value that can be calculated for given shapes. I personally am trying to call this the rotational inertia because it helps us understand it a little bit better. So this moment of inertia is proportional to the mass of the object, times the radius of that object squared. So if you have a bigger mass, you're going to have more rotational inertia. And if you have a bigger radius, you're also going to have a bigger rotational inertia. So if I was to think about, what about a hoop versus a disc? So a ring versus a solid disc. Which one of these things would have more rotational inertia? Well, if they both had the same mass, that hoop, that ring, has more of its mass that's located at a bigger radius. So more of its mass is located at a larger radius, which means it will have a greater rotational inertia. That disc has mass that's located at small radii and at bigger radii and bigger and bigger and bigger and bigger. And so that disc, because it has some of its mass that's close to the axis of rotation, it's going to be easier to turn than the hoop. Remember that rotational inertia is the object's tendency to keep doing what it's doing. If it's sitting still, is it going to be harder to turn? And the answer is the ring will be harder to turn, so it has a bigger rotational inertia.